Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's SecurityBoulevard.com webinar, brought to you by TechStrong and Wallarm. My name is Cody J. Brown. I'm the host of TechStrong Learning. We have an exciting presentation ahead, but first, I need to cover some housekeeping notes. First, today's session is being recorded, so if you miss any of our discussion or you'd like to rewatch, the recording will be made available shortly after we conclude today's on-demand session. If you have any questions for our speaker today, we want you to use the Q&A tab on the right side of your screen. And if you just wanted to contribute to our conversation or let us know from where you're tuning in, we want you to use the chat tab. Finally, at the conclusion of our webinar, we will have a drawing for 4 $25 Amazon gift cards, so stick around. So on to our topic today, we'll be discussing the 2022 API Security Checklist. And I'm joined today by Stepan Ilyin, co-founder at Wallarm. Stepan, thank you so much for being here with me today. I'm going to go ahead and turn the floor over to you.
Thanks for having me, Cody. Happy to talk on the API security. I give this practical guide on how you can protect APIs. So it would be very helpful not only for the security teams, but also for developers. Something that they can just watch and they try and implement right away. Talk with your teams in different parts of the orgs. It can be developers, it can be QA engineers, it can be our security teams overall. So wherever you are working, like it can be anything. So like happy to talk on that. What is the API security checklist? So first of all, this is something you can download. This is what we try to back with a lot of practical knowledge of what are the threats, what are the things you can do to prevent those threats become really dangerous for your environment, in your APIs and apps. Like what tools can you use to protect your APIs, to test your APIs, and so forth. So it's a document, and I'll give you a link so that everybody can download it. But today we'll cover it. So like we probably wouldn't have time like to cover everything, obviously, but I'll pick the most important parts of the API security checklist. We'll dive in, talk on different kind of specifics, and we probably will go through some of the parts of the API checklist very quickly. But anyway, you can use it, you can download it, and it would be very helpful for you, like regardless on which part of the org you are working on right now. So let me start. And first of all, let me say this. Some of the people we're talking with, they say, hey, do we really need to think about the API security, right? Because like, yes, we do have APIs, but most of the assets we have, they are apps. And then you start asking, and what specifically do you mean by app? And like it turned out that actually the company has a mobile app, and it talks with the mobile backend, which is an API. Or they have something like our single page application, and it's a React application that talks with the API again. So like APIs are the new apps. And if you take the data from the Akamai, 83% of all the web traffic are APIs. And if you talk with Gartner will say that 40% of the attack surface is already in the form of the APIs instead of the traditional web user UIs. So like it is there. Like while thinking about the product security, I would say you need to think about both application security and API security. And like it's so overlapping, it's really hard to distinguish all one from another. So let's start with the first one. And the way how this whole checklist is organized actually is by having multiple sections. So it's improper API security management discovery, next API abuse, then injections, then project object level authorization, and so forth. So we'll cover some of them early on, and I will give you details. Some of them we'll skip today probably just for the sake of time. And in the end, I also want you to show a demo of some of the open source tools, but also some of the projects that we're working on. So let's start with the first one, which is you can see the thread. It's on the left side with a different kind of explanation, what kind of thread it is. And on the right side, you see the checklist, because we've been thinking how to make this document super helpful, something that you can use right away. And I think the checklist way of representation data is the most important thing, right? You can just like go through everything, every line here, and see, okay, done, done, not done, put this in the backlog, and you will have a good picture, good overview of what you have at the moment. So the first section is improper API asset management and discovery. And this is probably new. Like, we always talked about the attack surface, about the assets discovery, especially in the larger org, for sure. But APIs bring so much more. It's especially for the larger companies, if they have multiple teams, like hundreds of teams, every single team works on some kind of APIs. Very soon, nobody in the company actually knows what APIs they have, what data those APIs expose, what versions of those APIs are actual, which versions of those APIs are deprecated, and so on and so forth. There's just like no single person in the whole org who knows everything. Those APIs expose data, like they are there, they're sitting, they're working with the up-to-date mobile apps, they work with some legacy app for compatibility issues, and so on and so forth. So like APIs management is as important as ever. So, and you just need to think about it. It's a new attack surface. So there are multiple things that you can do that can help you. So first of all, you need to have an inventory of all your API infrastructure. And I'm speaking here both on the testing and production, understanding of who can access like different kind of items, and so on and so forth. Secondly, you need to do the continuous API discovery. Like this, it's good to have like one-time API inventory exercise, but in reality, you need to do this API discovery all the time. You need to identify changes in APIs. You need to find like legacy APIs. You need to find zombie APIs that are deprecated but still exposed. You need to find shadow APIs that nobody actually knows about, and so on and so forth. And this is a process, and you need proper tooling for that. So like this is one of the important things that you need to have as a process, the new part of your SDLC, so to say. Then obviously you need to document every aspect of your APIs. And mostly we see that companies have open API specs, maybe not full, like in most cases they are not full, frankly, it's not everything, but you need to document everything. And that would include not only specs, that would include all the data on authorization policies, error reporting, security measures. So you need to have some kind of single source of truth that you can share with everybody. And this is a good hygiene exercise that every one of us need to do. So what you can do about that? Like, how to do this API discovery and API inventory? Like, of course, you can do something manually, but that wouldn't be only possible option. So there are some tools that can help you do that. So one of the tools actually that recently released, it's called API Clarity. It's an open source tool. So like we all love open source, right? That you can take and use free of charge. It works only in Kubernetes at the moment, but frankly, it's only in service mesh environments. But it already can give you the structure of your APIs based on their actual usage. So if you have the API, if you have like multiple APIs, you have traffic there, it's running Kubernetes. So this API Clarity thing will analyze all the traffic and will give you a picture of what is there, like what are the most used APIs, what are the specs, and so on and so forth. And it's open source, which is a good thing. Secondly, you can use, let me check, and if you can see it. So secondly, you can use some commercial tools. So like at Wallarm, we're working on the end-to-end API security solutions. Some parts of the product are free, some parts of the product are commercial, but API discovery is the part of our commercial product, which basically does the important thing to analyze all the traffic and figure out like what are the attack surface you have in terms of the APIs to show you all the specs, all the open API specifications in so-called Swagger format. So like if any of you are developers, you probably will see similarities to the Swagger UI right here. And as you can see, you can just go through all the APIs here and you will get all the details about the parameters, about the type, about the if this parameter is required or not required. And this is a non-stop process. So like as you have more APIs, we will show you like what are the new APIs that will head up here. You can look for different kind of specs. So like it's available to every customer. And the way it works is basically in your infrastructure, we are analyzing your traffic with a special Wallarm nodes. So the traffic stays in your environment, and you will see the full picture of all your assets, full API inventory in your UI, with the extra couple features are on the security side of things. So I will show you more on top of it, but the important thing here is that there are tools out there that can help you with the API inventory. So like obviously use some kind of tools to document your APIs, but there are some other tools that can help you give visibility into what is happening in real time in your environment. Let's move later. So like this is, by the way, a screenshot of what I've just showed you in a demo. So like you can have the full picture of zombie APIs, shadow APIs, methods, endpoints, and you can download the schema. So like one of the use cases that we see, people actually download the schema that is generated by the traffic and compare the schema with the docs they have. And there is always some kind of differences that the companies, especially the larger ones, are not aware about. Switching the gear to the next topic, API abuse, lack of resource, and rate limiting. So APIs are supposed to be used heavily. So it's a pretty common thing that you have an API and it's used by partners, it's used by the applications. And in many cases, API can be used not even by a human, like it can be used by other applications, other APIs. So the traffic can be massive, right? And it makes it challenging sometimes because a lot of bad guys in the world, they can abuse APIs. They can like create like a high volume of traffic, a high volume of requests. They can like run the application levels DDoS attacks on those APIs. And that's what we see all the time. So one of the important thing, kind of fundamental thing actually, to think about protecting your APIs against different kind of abuse. And the good thing is that there are a lot of things you can do right away, right? So first of all, you need to implement rate limiting. So for every API endpoint, you need to have limits of how many requests a client can create. And this is just like you can't live without it. Like if you don't have API limit, you will have a lot of problems. So I will talk about the API limits later. You also need to implement like size limits to the size of submitted parameters, arrays, and everything else. So that would just help you like against some parts of the DDoS attacks. You need to validate all the user submitted, all the data that is submitted by the users, because this is just an important thing to do. Our bots can create a lot of issues. So, and this is it's a very big topic actually, how you can prevent bots against abusing your APIs. But there are some of the things that you can do with the open source tools, frankly. You can also block the traffic from our unwanted regions, data centers, doors, anonymous proxies, and so forth. So like if you know that you will not have, if you only sell in UK and you know that like nobody else is important, you can just like start accepting requests only from UK. It's not perfect, it's not ideal, but in the way, like when you're under attack, I think this can be a good measure temporarily to restrict the access by allocation. So that might be an important thing to do. There are some other parts here, but I don't want to cover everything. So rate limiting is probably the most important part, right? And of course, most of the companies have already some kind of rate limiting. They have load balancer, or they have API gateway, and in many cases, they have something configured. But in reality, when we talk with the customers, and we talk with a lot of people who are concerned about the APIs, it turned out they don't leverage what they already have. They don't leverage the tools they already have in place, because even with the load balancer, something like Nginx or Envoy, you can create like the rate limiting with a very easy configuration. So like this is a simple configuration for the Nginx where you can just create the rate limiting for 10 requests per second, and that would be like something that you can work, and it can actually protect you against different kind of abuse. For the Kong Kong, which is an open source API gateway, Tyke, which is also an open source API gateway, you can have a UI where you log in, and you basically set what is the rate limiting. Guys, can you hear me?
We sure can.
Yeah, okay, that's good. So if you have infrastructure like Amazon, you can also use the Amazon load balancer. You can use other tools and solutions. So like leverage what you have. Like this is the first recommendation actually. Then you can start using something on top of it. So you can block the different kind of geographies. So like, as I've said, like for the Nginx, for instance, you have this HTTP GeoIP module. No, like be aware, like GeoIP data is not completely accurate. You will have a lot of issues with that. You can also block some of the providers. So like if you know that nobody actually is coming from the data centers, like you shouldn't supposed to have requests coming from the GCP or Azure or AWS. You can get the IP ranges for those providers and just block them, which is a very easy thing to do, right? And this is just an example of like how this data for the Amazon looks like. So it gives you with the API, like, or the special file, like all the data on the IP ranges that they have. What else can you block? You can block Tor exit nodes. You can block proxies and different kind of anonymizers. A lot of those fees are actually paid, but you can find some free ones. And you also can block some malicious IPs from honeypots and so forth. So another thing to do is like to use extra solutions that are specifically built to protect against API abuse. And Wallarm have this concept of triggers where it can basically configure that you want to block. Let me actually show you. So you can go to triggers and you can create the advanced rate limiting. So like, for instance, this is what we do for our own environment. We have this v2/token API method, and you can set up different parameters here and different conditions if you want to. So I can say, hey, if there are more than 30 requests from the very same IP during the 30 seconds, I want to do the following stuff. And like you can set up actions, right? Like you can say, hey, I want to consider those requests to be a brute force attack. I want to blacklist this IP address. Or I can like send them to this gray list, which is a kind of like a version of the blacklist, but a little bit more smarter. So everything here you can specify and you can create this rate limiting. The important thing is that this protection will be distributed. So like in case with the load balancer, you usually configure the load balancing, for instance, in the Amazon. But if you would have some of the APIs or the instances of the APIs in multiple locations, something in the Amazon, something in the Google Cloud. And by the way, multi-cloud is a big trend right now. So we can configure this API abuse prevention like in one unified section, and you don't really need to. Actually, I just realized that I didn't show you the demo, right? So like this is what I wanted to show you. So there is a trigger interface, and you can create what we call advanced rate limiting. So if there are requests from the same IPs, 30 requests from the same IPs per 30 seconds that are coming to the specific API endpoint. And you can specify a lot of things, actually. You can create a condition by saying, hey, I also want to take a look at the user agent here. And if it has curl command, for instance, I want this to be considered as a condition for the trigger. And then you specify the action. So like this is what you can do. And as I've said, you can do it across your infrastructure, across all the multi-cloud environments, across your Kubernetes environments and so forth. Let me get back to the slides. You can see slides, right? I'm sorry, guys. I'm still getting used to this platform. I'm using it for the first time. Okay, so you can see the slides. Perfect. Injections. This is the next topic, and like we all remember, all Waff's top 10, where injection is the one of the most important, like most of the dangerous threat for our applications. So like this is also valid, like not only for the applications but for our APIs. And we all know what to do, right? Like first of all, we need to validate and sanitize all the input for the client. We need to make sure that all the input is properly escaped. But we also can do like extra stuff specifically for the APIs, right? So one of the things you can do is to apply so-called like API, like to validate, like to use your schemas, frankly, for your APIs and validate all the incoming API requests. And what I mean by that is basically you can check if the API call that is coming is matching the schema and make a decision if you want to have this API request hit your API backend or not. So I will show you some of the examples for that. Another thing that you can use is to use API threat prevention tools, something that can analyze your traffic in real time and identify all the requests that can be malicious, that can be a threat to your APIs, are like REST APIs, GraphQL APIs, but also APIs that are based on WebSockets or APIs based on the some kind of other protocols. So like you need to make sure that the solution that you have supports all the protocols that you have in production, because otherwise there would be blind spots and you will be surprised like that. There are only few solutions in the world that can actually provide the protection for with the full protocol support. So let me give you some practical things that you can do. So one of the first things that we usually recommend is to use the API firewall. As I've said, it's a very easy concept, right? It's very easy, but pretty powerful, actually. You take your open API specs, you upload the specs to the API firewall. So like this API firewall works as the reverse proxy, and you can put it to your environment, and basically you can analyze and check every request that is coming to your APIs against the spec and send only those requests that are matching the specs. And the same you can do for the responses. So I'll show you this. So this is an open source project. A lot of companies actually sell this, like call it API security. So we decided that this should be a contribution to our community. So like we open source it. You can go to the GitHub Wallarm/API firewall and can download it. It's also like we distribute it as a Docker container, and it's official Docker container right now. So you can go to the Docker Hub and you can download it, like with all the docs and a quick start guide of how to start using it. This is just an example of how it works. So basically, you see there is a valid request that is coming to the API, and we know that the name parameter should have a string. So like it shouldn't have numbers. It shouldn't have anything else. So if we see that there is John in the name, we say, okay, this request is good. Let it go through. Or if we say that there is a number there, like it's like numbers are not supposed to be a part of the name, so like we want to block them. So it's purely based on the API schema. So the next thing can be that can be helpful and not helpful at the very same time. So like it's a very tricky thing actually. You can try and start and use Waff. So the problem with the Waff, and Waff can identify some kind of injections. The problem with Waff is that most of them, they don't really understand the structure of the request. So you can use mod security, but the way it will work is that it will apply all the rules to the whole request. And for example, like in situations when you have JSON and there is something encoded in the base 64, those data that is encoded in base 64 would be kind of hidden. Like not like Waffs wouldn't see it. Like they wouldn't be able to do anything at all about that. So that's why I encourage you to think about this option, like to think about the Waff, but be aware that you wouldn't be able like a lot of capabilities. And we're at Wallarm, we invested a lot of time, actually years, in implementing what we call deep API request inspection. So like it's super fast analysis of API calls, like near zero latency, frankly, that we do in real time. So like the nodes would be deployed as a reverse proxy. We'll talk about that. But what it will do what we call intelligent parsing. We will automatically understand, okay, it's JSON. We will apply the parser for the JSON. Then we will like see what kind of key values in the request are, and if we see something is encoded in base 64, we will automatically apply the next decoder, and we'll see what's actually inside the base 64 encoded data. So you will have this full visibility. And the most challenging part is actually to make it fast. So like we basically made it so fast that like a lot of like top tech companies in Silicon Valley, a lot of e-commerce companies, they can use it. And we're happy to provide them not only detection part, but also mitigation. So if we see that some request is malicious, we can just block it right away. And you don't need any extra tool. You don't need an integration with anything else. You can just have it there. Actually, let me maybe show you a little bit of how it looks like. So I'm switching to the screen, so hopefully this time you will see this. I think I did it. How it looks like, so like this deep API request inspection. So basically you can go to the UI and you can see all the events that we identify for your API infrastructure. And you can see like 25 attacks are happening right away. Like right now, there's like, this is demo environment, and there's some of the attacks like kind of attacks in our laboratory, but like some of the attacks are real attacks because there are so many bots that are scanning the internet. And when I'm saying that we can provide you full visibility and we will provide you deep API request inspection, this is just an example of malicious request. So we see that there was a malicious request that is coming against this API endpoint / API send, and this API endpoint, it has obviously it's a REST API, so it's a JSON with all the names and parameters, and you can just like see what was inside. So you see that there is a malicious payload, cat etc password. You can see it here as well. So like we always show you like what was there, like why we believe that this request is malicious, and you have full visibility of what is going on. So all this data was analyzed in real time. Our like parsers to analyze JSON were applied, and we identify the this malicious payload, and we basically blocked it in real time. So like this, it works like that. Let me get back to the slides now. So the next thing, project object level authorization. Like a lot of people call it BOLA. It used to be called a very related thing is insecure direct object reference. So this is a purely API specific thing. And if you open the API WAS top 10, like this is would be the #1 in the list of API security issues. I wouldn't say that this is the most critical thing, but this is definitely you need to think about, and especially your developer teams need to think about, because those attacks, like it's possible to detect those threats, and it's possible to like find it like with testing, but a lot of those things are really relying on how your developers are write the code. And there are a few steps that you can take to fix the broken authorization. So first of all, you need to implement an authorization mechanism that checks whether the logged in user has permission to perform an action. So like it's as easy as that. And you make sure that you have this mechanism actually in all the functions, because what we see all the time is that the company actually has like all the controls in place, but they are not applied everywhere. And like there are some APIs endpoints that don't have these controls for whatever reason it is, and they actually expose sensitive data. and this is really, really bad. Another recommendation is to use randomly generated IDs, because like that would be hard to guess for the objects, for the object identifiers for user requests. So let me show you a few examples. Those examples are coming from the API OS top 10. So like you see in the scenario number 2, there was a header with the ID of the user. So and this is just like digits, like 54796. And when the attacker was replacing it with a 54795, like the attacker could receive a successful HTTP response and able to modify other accounts data, which is wow. And this is just like one of the examples of that. Or another example is of having this pattern for the APIs /shops. Then there is a shop name coming, and there would be the revenue data JSON. So what the attackers can do is to get the list of all the hosted shop names, and then with a simple script, it can actually manipulate the name of the list and use these names in the URL and get the data for those sales data. So like, once again, it's only a vulnerability when it's not properly configured. So those would be recommendations to think about, like working on the BOLA. And this is, I highly recommend to take a look at the API OS top 10 and take a look what is written there. Another thing which is also related is broken user authentication. So this is another very related vulnerability, because when you have user authentication that is not implemented properly, it can just render all the other security measure obsolete, because like technical flaw in user authentication can allow malicious parties to impersonate legitimate users, and this just like would be one of the example of that. So authentication is very important, and one of the very first recommendations that we usually give here is that you don't want and you don't need to, and like frankly you need to avoid it by all the means, implement your own way to implement authentication. So use the standards, use something that is already there, like JWT for the authentication process, because there are a lot of best practices. There are a lot of bad practices, by the way, as well, that is distributed as a best practices. So, but you don't need to implement it and like think from the scratch. There are a lot of patterns that are available out there that you need to choose, understand, really understand, like with all the details, and start implementing and applying to your infrastructure. Another thing to think about is you need to identify and document all the endpoints that can be used to authenticate with your API, and you need to ensure that they are reviewed for possible leaks. Another thing, you don't need to return any sensitive information like passwords or tokens directly in API responses. You just like try to avoid this. There are some other things to cover here, like everything would be in the API security checklist, but this is the most important part probably. You just need to choose the right authentication methods and try to implement all the best practices. And you can, frankly, the topic of only GWT will take like another 5 webinars of how to do this correctly. And you will find a lot of webinars on this topic, by the way. But like the number one recommendation is that make sure that you have like everything related to authentication done right and implemented across all your APIs, across all your microservices, across all your applications, and all the developers understand it. Another thing is excessive data exposure. So this is what happened a lot, and this doesn't necessarily mean that you expose like some sensitive data or PII data, but in some cases you do. But in many cases,
Hey, Stepan, your audio has cut out. So I'm just going to go ahead and refresh you real quick. Thank you for your patience, everyone. We're going to have him right back up with us.
Can you hear me now?
I sure can. The floor is yours once more.
Yeah, thank you. Thanks for the heads up. Yeah, so like this is what you can do, and excessive data exposure. So like as I've said, it's not necessarily exposing API data, which is the most critical risk, obviously, but it's also like the situation when you can expose data that is just can give the attacker some information about your APIs that you don't want them to have. And there are some things that you can do. So like you can limit the number of records that can be affected, like fetched by a querying API. You can return only the data the client's requesting from your API functions, rather than returning all available data and expecting the client to filter it. But also you can validate API responses. The way how you validate the API requests, you also can validate API responses. And actually, this can be very powerful. Let me switch my slide. So getting back to the API firewall, this open source firewall, API firewall from Wallarm. So this is the screenshot from the docs. So as I said, like you can set up the request validation when you can actually match the request with the specs. But actually, this works for the API response validation as well. So like as you can see, there's a special parameter. It's called API firewall response validation. And in this case, we will validate application responses, and we'll check if the response matches the spec, which is can be quite helpful for this specific risk as well. Let's move on. Another thing is the broken function level authorization. So once again, it's one of the threads that is written in the API of Top 10. And one of the most important thing you can do probably is to centralize all your authorization code so that you know what it is. It's something that a lot of people in your company understand and can regularly review and vet, so that like you just know that this particular piece, which is super critical for the authorization, works. And there's another topic of like there is a whole topic on its own, but in the checklist we just give you a few recommendations that you can start doing right away. Mass assignment is another thing. So like basically the flaw that allows attackers to modify objects by guessing property names or endpoint addresses that shouldn't be accessible. So this is a very often vulnerability actually for the API. So like I encourage you to read more details on that. But something that you can do to prevent this mass assignment attacks is to first of all, do not directly assign user inputs to the objects in your API functions. Second of all, you can explicitly define the object properties that the user is able to update in your API call. And the third thing, you also can enforce validation and data schemas so that the only approved properties will be used by your API function. So like this would be the three things that you can do right away for the mass assignments. So like feel free to use it. Security misconfiguration. So this is a very broad thing. And frankly, one of the issues with all the ways to categorize and like to have these multiple groups of threats is because like all of them are so overlapping, right? So like security misconfiguration can be everything. And it can be something related to the course policies. It can be something related to the using the outdated software, and so forth. So, but this is one of the major things. And what we always encourage is to have different kind of checks and controls and testing procedures that can help you to identify different kind of misconfiguration issues. So what you can do here. So we're first
Hey, Stepan, we've had it happen again. I'm going to go ahead and refresh you. Thanks for your patience, everyone.
Now?
And you're back.
Yeah. I don't know what's happening, guys. Sorry about that. So we're set up the course policies for the APIs that are publicly accessible from browser-based clients. Are only allow API access using necessary HTTP verbs because this will help you to reduce the attack surface. Limit all clients' interactions with your APIs and other resources such as linked media to secure authorized channels, and basically use tools that can help you to find all those misconfiguration issues. So let me show some of them. At Wallarm, for instance, we have this. Let me just share my Chrome tab with you. Can you see the demo, guys?
We can.
Yeah. So like one of the important things that we have is what we call scanner. So we basically can identify the attack surface not only based on the traffic, but also like using the scanner and testing tools that are sitting in our cloud. And then what do we have? We can like test a lot of your assets for different kind of misconfiguration issues. And the way how we group them together is by the CWE score. So like CWE, not score, CWE groups like information exposure, like improper input validation, or improper access control, or using components with the known vulnerabilities. So like we basically implemented a lot of checks that are really related to the misconfiguration issues. So like, and this is what you can get and start using right away. So there are multiple open source tools. I will talk about them a bit later during this presentation. So, but just be sure that you have options. And yes, it's all about how your developers write code, but also are about what you can do with the different kind of tooling that can help security teams to identify them. The next thing is insufficient logging and monitoring. So, and we can talk a lot about that. I think the name is self-explanatory, but you just need to have data to be able to understand like what is happening. Are you under attack? What kind of APIs are under attack? Do you have some kind of users that try to log in like with thousands of different user and passwords? You need to identify source of the problem quickly, and for that you need data, right? So I would encourage you to log all authentication authorization failures. We'll encourage you to log request details that can be quickly identify the source of an attack using the API security tooling. We will encourage you to treat logs as sensitive data, frankly, as they may contain data about the vulnerabilities. So because you don't want to have your data exposed in the logs. And there are a lot of tools that can help you like to get this visibility. Let me show you this. Let me switch first to my. So having the tooling in place that can provide you visibility is very important. So I will show you a few options with the open source solutions that can give you like dashboards, that can give you data about the attacks, that will give you the search, that will give you alerting, kind of packed together. But in most cases, like if you don't have capacity of the team, like if you don't have engineers to do so, like we highly encourage you to use commercial products. And obviously, like I'm biased, so like we're working on the Wallarm. So like I would encourage to use Wallarm because in this case, you just have full visibility. Like you can have like all the breakdowns, like what is happening, like how many malicious traffic do you have, like what is the breakdown for the attacks against your which like different kind of applications and APIs you have. You will have the breakdown, like what kind of attacks you see, where those attacks are coming from. You will have the vulnerability scanner. So like you have full visibility, and you always can get the details. So if you know that something odd was happening at some particular date, you can just get the details about this date very quickly. And what we also try to do is like basically minimize the amount of data you need to analyze, because you will have a lot of events, you will have a lot of attacks. What we try to do is get those events together, group them together, so that you can actually see, okay, this is the some kind of invalid XML that is coming, or there is also the SQL injection attack against your REST API, or it's not a REST, it's GraphQL API. And you will see like every line here is basically a request, and you can expand and you can get like more details about like what was the query for this GraphQL request. Like it's all here, and you just have this visibility for everything to understand like what was going on and when. Getting back to the slides. So one of the things that I promised you to show is to list some of the options for API security testing, right? So there are multiple options, and a lot of them are open sourced. So there is Zap, which is a project from the OWASP. So it has some limitations, like it doesn't have gRPC support. And frankly, it was originally developed for applications, not really for the APIs, but it can be really helpful. Yeah. Our second thing is Wrestler or Dread. So like those are open API based fuzzers. So you can basically upload the open API specs, and those tools will help you to identify vulnerabilities. And yes, it's tricky because those tools would know everything about the state and everything else, but they can actually help you to identify some of the issues and flaws. Another thing is schematics. So it's basically the same as Wrestler, but with a GraphQL support. So GraphQL is evolving. So there is some data that by 2025, 50% of all the GraphQL API, 50% of all APIs would be GraphQL. So we'll see if it's true or not. But what we see is that definitely GraphQL is up and rising right now. There are some things that can help you to test your APIs for the volume-based attacks, like AB, which is like most of you probably used, JMeter, and everything else. So like if you want to make sure that like your APIs are protected against abuse, those can be a good thing. And also there is Go Test Waff. And don't be fooled by the name Waff there. We probably should rename the project. It's our open source project that can help you to understand like what is the level of protection of the APIs and apps you have right now? What attacks can be detected? What protocols are covered? Like, can your existing security solution, because most of you already have something like WAF, right? But is it really capable to identify the attacks against, like API-based attacks? Does it support WebSockets? Does it support gRPC, GraphQL, and other technology that your team start to use? That's a question. And so this is the tool that can actually give you a quick answer for that. Like it's distributed, like it is on the GitHub in the GitHub Wallarm repository. So you can download it and basically run the check against the site that you need, and basically get the incident report about that. Then we're moving further. Another thing that I promised to you is a kind of like the set of the open source tools that can help you get visibility. So what I think is a good thing to use is the combination of multiple solutions. So let's say you have a Kubernetes cluster, and at the Kubernetes cluster, you can plug in different options. So you can have API firewall there, you can have a WAF there, and basically ingress controller, so-called load balancer in the Kubernetes environment. So you can log everything you want here. With the help of Fluentd, you can get those data and put it into the Elasticsearch. and then you will have like all the data searchable. So like you would be able to find everything there in one place. Then you can add Kibana, and this would be the way how you can get the visuals, different kind of dashboards and reports. And then you can also add the something like a last alert. This is open source project from Yelp. So this will help you to get the alerts right away in Slack, for instance, like if something is off. And like I don't think we have time to go through all the configuration, but this would be in our slides. So like you can easily set this up in your own environment, and it can be ingress controller, it can be something else, like it can be just like Nginx load balancer, for instance, or it can be like Kong API gateway. So like it will be more or less the same setup. And in our slides here, we have all the specs. So this would be example of what would you have in Elasticsearch. That would be some examples of the dashboards that you can get. This is also the example of different kind of alerts that you can have in Slack or whatever. For instance, you can say, hey, if there is something that is some type of the events like injection attacks are in Y period of time, like kind of frequency type of alert, and you can have a Slack message, for instance. So it's easy to do, and there are like multiple options are available to have it. Let me switch. I think this is more or less the main part for my presentation today. So, but let's, since we have some time, I just want to show a little bit more about the product we're working on, because it's so related to the APIs. And then, yes, we talked about a lot of items that you can use, and a lot of tools, like free tools and open source tools that you can start using right away. But in many cases, we just like made it easier for you to just start using those things. So once you have everything installed, and by the way, let me show you maybe next time. So you can install it as a module for load balancer. You can install it as a ingress controller. All the images in the Amazon, Google Cloud, they're all available, so you can get it there. We support Envoy proxy, and it's basically whatever tech stack you're using, we can come and find the way how we can plug in so that you have this API security layer right away. So like you will have everything in one place, and you will have visibility across all your environments, about all your across all your multi-cloud environments. So you will have like visibility of your attack surface from the outside, like what are domains, what IP addresses. You will see the API structure that are created based on your traffic. So like this is not what is people upload. We never will ask you to upload any API specs. It's another way around. We will actually give you all the data in the actionable format. So you can basically go through everything here, and you will see like full visibility. Or you can click download, open API specs, and download all the specs there. Then you will see the breakdown, like what is happening and when. Like how many requests and API calls were analyzed, how many attacks were detected. The full breakdown, like for API number one, like let's say it's your main e-commerce website. Then you have APIs for the billing. So we'll have this breakdown for all the categories of APIs that you have, and you will see how often those APIs are attacked and where these attacks are coming from. Then you can go further and you can say, hey, I want to see the details of what was going on some particular day, like our second part of the February. And as I've said before, we try to minimize the level of noise for you, because you will be swamped. Like if we will just dump everything that we will see, you will be just swamped. That would be actionable. So we try to group together everything that's related, and you can just see with the full details, like what is going on, like what is the attack, what API endpoint is affected, what was the parameter, what were the malicious requests, what is the content of those requests, what was the malicious payload there, who was the attacker, where's the attacker is coming from, is this attacker coming from the data center, is the attacker using VPN service. So like it's all here, but it's not everything. We also do some extra stuff. So do you see this green check mark on the right side? So for many of the attacks, we actually can validate. We can come and say, okay, we detected this attack and we blocked it. But do you want to know more? If so, you can turn on what we call active threat verification. And in many cases, we can validate, like, do you really have this path to reversal kind of attack for this API endpoint or not? Because if you don't have any vulnerabilities, you don't really need to care. Yes, there was an attack, but like the attacker is not able to exploit anything. And if we say that there is no vulnerability, we'll say, hey, everything's safe. Even though you had this attack, you don't need to worry about it. Or another way around, we can say that, hey, you have an incident. So this is like just an example of the day when there were like almost 4,000 of attacks, and there was only one incident. And you can go into the details here, and you can find like what was the incident. And like for every incident, there is also related vulnerability. So in this case, it's the vulnerability which is information disclosure. So like, do you remember we've been talking during the presentation about the data excessive exposure? So this is one of the vulnerability, and we do this actually with the passive analysis. So we saw that in the response, there's a minor which makes us feel that this is actually the shell that is downloaded there, but it can be also the stack trace or error or something else, and we will just show you that this is probably a security incident. All the vulnerabilities, you can go to this page and you can see the full list of it. Do you remember the log4shell? So like purely, I'm pretty sure you remember all those things. Our Christmas was ruined because we were helping customers to protect themselves against log4j everywhere. And this is just an example of the actually API that was vulnerable. So you see all the details about the log4j. You see all the related requests that we consider to be incidents, and you can see all the details about the exploit example. So like it's all here. And when you want to set up the protection against API abuse, if you want to set up the alerting, some kind of events that you want to see, you go into the triggers and you can create the triggers like for whatever you want. So like this is, for instance, for the OAuth token. So you could just basically say if there's like more than 5 requests coming per minute, I just want to ban this IP address. And if anything banned, like you can see what is going on, like what is in the whitelist, something that you don't want to block never. Like what is in the blacklist, like what kind of countries do you want to block right now? What is in the gray list? So the gray list, by the way, it's an awesome example of how you can start using this product in the blocking mode, because this would be kind of a smart blocking thing, a smart blocking mode where you wouldn't be afraid of the false positives. And by the way, speaking of the false positives, we just invested a lot of time to make this solution very accurate, both on the false negatives and false positive sides. And I know that we are running out of time, so let me say, before we move to the question and answers, encourage you to go to the website and request a demo and try the product out. Happy to talk with you. And let's take a look at the questions that you have. So the question number 1, does Wallarm or your partners offer an API gateway? So we basically partner with the API gateways. So if you use Tyke, if you use Kong API, if you use APG, you use MuleSoft, so there is a way how we can integrate together, and we are working on the joint solutions with those companies. So this list is not unique. So if you're a user of WSO2, for instance, we can still work together. And our commitment is basically to support as many API gateways as possible. So happy to chat on that. Another questions, what would you say are the top 3 API security concerns? I would say you just, like, nothing really changed. Like, even though we talk about the API security, it's all about the product security after all. And like, we all remember things like injections or path traversal are from the applications, and they're still applicable to the APIs. Yes, there are some new threats like Wallarm and more API-specific things, but I would say that you just don't need to separate all those things. Think about the product security and have this full picture. Like, you don't need to separate API security threats and application security threats. It's all there. What is the use case for CI/CD or DevOps tools you have highlighted in one of the slides? I don't remember what was the use case, but speaking of the CI/CD, so like one of the things that you can try to use is to use different kind of open source tools to run the tests for your APIs or for the APIs that changed using some of the open source tools. And some of them are dynamic testing. So by the way, like Wallarm has its own tool. It's called Framework for Application Security Testing. So you can just incorporate it into your CI/CD pipeline and run the security checks and find vulnerabilities before the code actually goes to production. What do you think? How easy is it for a Java developer to deliver all the needed information? I think this is the last question as we're running out of time. I think it's not a rocket science, guys. So like all of those things are applicable. There's so many data on these topics. There are so many best practices, and we try to this is the whole purpose of this actually API security checklist, to make it very actionable so that you can read it and start using it. And I think it's pretty easy for any developer in the world. And I think this was the last one.
Awesome. Well, thank you so much, Stepan, for putting together this presentation and showing our audience an in-depth demo that they can apply directly to what you've just been talking about. So I really appreciate you taking the time and going in such great detail for us. Do you have any closing remarks before we officially close out?
I just encourage everybody to download so like go to the Wallarm website, go to the resources, and download this API security checklist. We'll ask you to fill out the form, sorry guys, but it's free, so just like have it there. If you have any API security project or any web project or anything related to the API security, so go to the website, request a demo. Like hopefully we can help. If not, we will just guide you through to the right direction. So if there is any open source tool that can help, we will say, hey, you don't need Wallarm, just use that. So we're very customer friendly and happy to help everyone.
Awesome. Well, thank you so much for being here today. I'd like to quickly remind our audience that today's session was recorded. So if you missed the beginning or you just want to rewatch, you can find the recording living on the Security Boulevard website. Just visit securityboulevard.com/webinars. Quickly, we do have some Amazon gift cards to give away. This is for 4 $25 Amazon gift cards. Our first winner is Naresh C. Our second winner is Amir S. Our third winner is Sean F. And our fourth winner is Jin A. So congratulations. Keep an eye on your inbox to claim those gift cards. And if you don't receive an email, just check your spam folder. I would also like to extend our gratitude to Wallarm for sponsoring today's webinar. And my final thanks goes to you, our audience. We really appreciate you joining us today. Please take a moment to fill out our post-webinar survey, and we hope to see you at a future TechStrong Learning webinar. Have a great rest of your day, everyone.
Thank you, everyone.